Salam everyone, welcome to Physics with Noshe, and we are discussing the CRO or the cathode ray oscilloscope. Now let's have a look at the structure of the CRO. So you have these X plates, Y plates, the anode, the cathode. We'll discuss what the purpose of each is, and the screen on which you see the image when this cathode is started. And inside this whole tube you have a vacuum. First of all, you heat up the cathode, and when the cathode is heated, electrons are emitted. This process is known as thermionic emission. The emission of electrons due to the heating of the cathode. Next, the anode is responsible, because you know the anode is positive, right? So the anode is responsible for attracting the electrons or for speeding up the electrons. So the purpose of the anode is that the anode is positively charged and is responsible for the acceleration of the electron beam. And the anode, the voltage that you apply over here is known as the anode voltage or the accelerating voltage. Now, a couple of questions before I go to X plates and Y plates regarding the cathode. The first question is, for the cathode, let's say you apply a source here, a DC source. So what happens is a current flows through the heater, the cathode is heated, and electrons are emitted. So when this cathode is heated, why does it get heated? Because a current flows through the circuit because of the cell. Now the question is, what would be the effect if I reverse the terminals of this cell? So let's say if the current is not flowing in this direction, what would be the case if the current is flowing in the opposite direction, like this? Would I have the same thermionic emission? That's number one. Number two, the second question is, what would be the effect if I change the voltage on the anode as well? Like let's say this end is positive. What if I make this end negative? So two questions. One, what will be the effect of reversing the cathode voltage? Second, what will be the effect of reversing the anode voltage? And to have a look at that, let's bring down this. So the effects of reversing the cathode voltage. If the cathode voltage is reversed, it will not have any effect on the emission of electrons. So current chahe यूं flow करे, current chahe यूं flow करे. No matter which way the current flows, it will not have any effect on the emission of electrons, since the cathode would still heat up. Now, reversing the anode voltage. If the anode voltage is reversed, so if you reverse the voltage, like if I remove this plus and I put a minus here, what will happen to the electrons? Think about it. The electrons are negative. The anode, let's say, becomes negative. The electrons will be repelled. So if the anode voltage is reversed, it will decelerate the electrons as they will be repelled. The image will not be formed on the screen because the electrons won't be able to reach the screen. When the electrons reach the screen, that's when the image is formed. Third, what is the effect if you don't have a vacuum? What if you have a gas inside? If you have a gas inside, the electrons would collide with the gas molecules, and again, no image will form. So you need the space to be absolutely empty so that the electrons can reach the screen. Now, before we go to the X and Y plates, I need you to understand the deflection of electrons by electric fields. So let's say you have an electron beam and you have a positive and a negative plate. The electron beam will be deflected upwards. Why? Because like charges repel and unlike charges attract. Similarly, if I reverse the polarity on these two plates, then the electron beam will be deflected downwards. Now let's say you have these vertical plates and I ask you to complete the path for the electron. So you know that the electron is going to move towards the positive plate like this, because like charges repel and unlike charges attract. So the electron is negative, so it will be attracted towards the positive plate. So this is a horizontal deflection. It will horizontally deflect. It's just like you're going on a straight road and you take a left turn, for example. So let's say you're going on a straight road आपकी left side पे the plate is negative, on the right side the plate is positive. Where will you turn? You will turn to the right, horizontally. So the difference between this deflection and what you saw earlier was that was vertical deflection, whereas this is horizontal deflection. So if you want now to understand how do the X plates work, this is how the X plates work. The X plates cause horizontal deflection, and the X plates are also known as the time base control. Why? Because on any chart, on any graph, what do you have on the x-axis? Time. So the X plates control your time base. Remember this. And now these two plates, which cause vertical deflection, Y plates cause vertical deflection, and Y plates are also referred to as the voltage gain. So like X plates have a name of time base, Y plates have a name of voltage gain. So these plates represent the Y plates, these represent the Y plates, because they cause a vertical deflection. Please yaad rakhe that the name of Y and X plates is coming from how they deflect. So Y plates cause a vertical deflection, whereas X plates on the other hand are given the name X because they cause horizontal deflection. So you should know that the X plates control your time and the Y plates control your voltage. So how high or how low a signal goes, that depends on your Y plates, and how much to the left and how much to the right it goes, that depends on the time. Alright, so time controls your movement in the X direction and the Y plates control your movement in the Y direction. We'll discuss all of these cases just next. Alright, so now let's discuss the different types of output waveforms based on different inputs. So DC power supply, time base off. You know that the time base is the X plates. So X plates are off, X plates are off, X plates are on, X plates are on. But what we'll change is the type of supply that we connect to the Y plates. So you connect a DC power supply to the Y plates. For example, what you see for the first one is this situation. You've applied a DC power supply. This is positive, this is negative. The electron beam goes up. So what does the image look like? When you look at the CRO screen, the image that you see is this. So this is the screen of the CRO and you see a dot. You see the dot is in the vertical direction. If let's say this plate was negative and this plate was positive, the electron beam would have deflected downwards. This dot would have been downwards. So remember, when you have a DC power supply, you will see a dot either here or over here if in case this plate becomes negative and this plate becomes positive, in which case your electron beam would be deflecting in this direction. But remember that you will either see a dot above or you'll see a dot below. Now, what if you connect an AC power supply? So if you connect an AC power supply, that means that for some time this is positive, this is negative, then for some time this is negative, this is positive. It keeps on fluctuating or oscillating. That's what an AC or alternating supply means. So your electron beam would be moving like this, because when this plate is positive, the electron beam would go up. When this plate is positive, the electron beam would go down. Then this plate is positive, the electron beam would go up, and likewise it would just keep on oscillating. Remember, the premise or the whole picture that you'd see in front is based on one rule, that opposite charges attract. So when you have a plus sign here, the electron beam goes up. When you have a plus sign here, the electron beam goes down. If the electron beam goes up again, that means there's a plus here. If the electron beam goes down, that means there's a plus here. Now, what does that mean for the output on the CRO? The output on the CRO would look like this. You would see a vertical line like this, because your electron beam is going up and it is going down. So it's oscillating like this. It is different from what you saw in a DC power supply, because in a DC power supply, you saw a dot. a dot either above or below, depending on which plate was positive. Was the upper plate positive or was the lower plate positive? But in case of an AC supply, you will have a line. So please note the difference. Now, to discuss the third case, the AC power supply. So you know for the AC power supply, you'll have this straight line. But what if you turn the time base or the X plates on? What will happen to this line? If you turn on the movement in the horizontal direction, because you know X is horizontal, right? And if you turn on the movement in the horizontal direction, what you will see is a wave, because the straight line will also want to move horizontally. So straight line खाली vertically move नहीं करना चाहेगी, वो horizontally भी move करना चाहेगी. As a result, the straight line converts to a waveform when both the plates are on. So to get an image on the CRO, you definitely need the Y plates to be on at all times. So Y plates off का तो case ही नहीं है. The question is, what will you get if your time base is off, and what will you get if your time base is on? If your time base is on and the Y plates are on, or on an AC supply, AC means it's fluctuating up and down. But if you turn on the horizontal movement as well, तो आप खुद सोचो एक चीज़ ने ऊपर और नीचे भी जाना है और आगे भी जाना है, तो वो ऊपर और नीचे कैसे जाएगी आगे जाते हुए? हैव अ लुक. उसने ऊपर भी जाना है और आगे भी जाना है, सो दिस इज द मूवमेंट. उसने नीचे भी जाना है और आगे भी जाना है, दिस इज द मूवमेंट. सो you'll get a waveform if the AC power supply is on and your time is also on. Now, why don't you take a minute to think about that this is the dot that you saw with the DC power supply, but the time base was off. But if you have a DC power supply, which means you have this dot, and now you turn on your time base, what would you expect? Just imagine it. Time base का मतलब है horizontal movement होनी चाहिए. What will you expect if this is a dot? What will that convert into? So I hope you've thought about it, and this is what you get. So that dot converts to a line. The reason is you will need horizontal movement because the time base setting is on, the X plates are on. So you can easily create this chart for yourself as a gentle reminder that if you have a DC supply, and your time base is off, you will always see a dot. If you have a DC supply and your time base is on, so this is DC supply and time base is on. Time base could cause a horizontal movement, right? So you will see a flat line. If you have an AC supply and your time base is off, you will see a vertical line. And if you have an AC supply and your time base is also on, which means you also want horizontal movement, you will see a waveform.